Download this code from codegive.com, link in the description below. Certainly. The Cuda out of memory error occurs when your GPU runs out of memory, VRAM, while trying to allocate resources for operations or models, especially in deep learning tasks using libraries like PyTorch or TensorFlow. This can happen for various reasons, such as large batch sizes, high-resolution images, or complex models. Steps to solve Cuda out of memory error. Here's a structured approach to troubleshoot and resolve this issue. 1. Check available memory. First, check how much memory your GPU has and how much is being used. You can use the nvidia-smi command in the terminal to monitor GPU usage. Bash nvidia-smi. To reduce batch size. One of the most common solutions is to reduce the batch size. Smaller batch sizes consume less GPU memory. Example asterisk. If you are using PyTorch, Python, import torch. From torch.utils.data import data loader. Assuming dataset is already defined. Batch_size equals 64 original batch size. Train_loader equals data loader, dataset, batch_size equals batch_size, shuffle equals true. Reduce the batch size. Batch_size equals 32 new batch size. Train_loader equals data loader, dataset, batch_size equals batch_size, shuffle equals true. 3. Use torch.cuda.empty_cache. You can clear the cache in PyTorch to free up unused memory. This doesn't free the memory occupied by tensors but can help mitigate fragmentation. Python. Import torch. Clear cache. torch.cuda.empty_cache. 4. Use mixed precision training. Mixed precision training allows you to use both 16-bit and 32-bit floating point types, reducing memory usage and speeding up computation. Example asterisk. Using PyTorch with torch.cuda.amp. Python. Import torch. From torch.cuda.amp import gradscaler, autocast. Model equals myModel.to, device. Optimizer equals torch.optim.atom, model.parameters. Scaler equals gradscaler. For data, labels in train_loader. Data, labels equals data.to, device, labels.to, device. Optimizer.0_grad. With autocast. Outputs equals model, data. Loss equals criterion, outputs, labels. Scaler.scale, loss, backward. Scaler.step, optimizer. Scaler.update. 5. Model optimization. Reduce model size, optimize your model architecture, for example using fewer layers or smaller layer sizes. Use efficient layers. Consider using more memory-efficient layers, like depth-wise separable convolutions. Prune the model, remove unnecessary weights or neurons. 6. Gradient accumulation. If reducing the batch size affects model performance, consider using gradient accumulation to simulate larger batch sizes. Example asterisk. Python. Accumulation_steps equals 4 accumulate gradients over 4 batches. Optimizer.0_grad. For I, data, labels, in enumerate, train_loader. Data, labels equals data.to, device, labels.to, device. Outputs equals model, data. Loss equals criterion, outputs, labels. Loss equals loss/accumulation_steps normalize the loss. Loss.backward, back propagate. If I+1, percent accumulation underscore steps equals 0. Optimizer.step, update weights. Optimizer.0 underscore grad, reset gradients. 7. Check for memory leaks. Make sure you are not inadvertently holding references to tensors that are no longer needed. This can often happen in loops. Use del to remove variables that are no longer needed. Python. After training on a batch, del data, labels, outputs, loss free up memory. Torch.cuda.empty underscore cache, clear cache. 8. Using CPU. If GPU memory is a persistent issue and performance is not critical, consider running your operations on the CPU. Python. Device equals torch.device, CPU, use CPU. Model.to, device. Conclusion. The Cuda out of memory error can often be resolved by employing one or more of these strategies. Start with the simplest solutions, like reducing the batch size, and then work your way through the more complex strategies if the problem persists. Always remember to monitor your GPU usage to understand how your changes affect memory consumption. Additional resources. PyTorch documentation on Cuda, https://pytorch.org/docs/stable/notes/cuda.html. NVIDIA developer documentation, https://developer.nvidia.com/cuda-toolkit. Feel free to reach out if you have further questions or need clarification on any point.